When we talk about computers today, we usually mean thin rectangles of glass and metal that sit in our pockets and somehow know more about us than our closest friends. They recognize our faces. They finish our sentences. They recommend what we should buy, watch, and sometimes even who we should date. It feels futuristic, almost magical. But the story of how we got here is far stranger and more dramatic than most people realize. Computing didn't begin with silicon. It began with gears, paper, human error, and a desperate need to keep track of things without going insane. Long before electricity, people were already overwhelmed by numbers. Governments had taxes to calculate. Merchants had inventories to track. Astronomers had to predict the movements of stars and planets. Every one of these problems required calculations that were tedious, repetitive, and dangerously prone to mistakes. So people started building tools to help them think. The Abacus, which dates back thousands of years, was one of the earliest examples. It wasn't a computer in the modern sense, but it was a way to offload mental work onto a physical system. Instead of remembering numbers, you could slide beads. That idea, letting a machine carry cognitive load, is the heartbeat of computing. The next great leap came in the 1600s when people like Blaise Pascal and Gottfried Wilhelm Leibniz began building mechanical calculators. These were astonishing for their time. They could add, subtract, multiply, and divide using intricate systems of gears and wheels. When you turned a crank, the machine physically embodied the math. It was slow and fragile. But it was something new, a machine that could follow rules to produce correct results. That concept would echo through every computer that followed. But the real turning point came in the 1800s with a man named Charles Babbage. Babbage was obsessed with eliminating human error in mathematical tables, which at the time were used for everything from navigation to engineering. These tables were often riddled with mistakes because people had to compute them by hand. Babbage's solution was radical. He designed a machine called the analytical engine, which would be powered by steam and controlled by punched cards, similar to those used in textile looms. This machine was never fully built, but its design was stunningly modern. It had memory. It had a processor. It could branch and loop. It was, in theory, a programmable computer. And then there was Ada Lovelace. While Babbage designed the machine, Ada understood its soul. She realized that this device wasn't just for numbers. It could manipulate symbols. It could follow abstract rules. She wrote what is often considered the first computer program, not for a machine that existed, but for one that might exist. That act of imagination is why she's remembered as the world's first programmer. Fast forward to the 20th century, and computing finally gained electricity. Early electronic computers were enormous, loud, and fragile. They filled entire rooms and consumed absurd amounts of power. The ENIAC, one of the first general-purpose electronic computers, used about 18,000 vacuum tubes and weighed over 30 tons. When a tube burned out, the whole machine could stop. Technicians would hunt through racks of glowing glass like electricians in a science fiction cathedral. These early machines were built for war. During World War II, computers were used to crack codes, calculate artillery trajectories, and simulate nuclear reactions. One of the most famous examples was the British code-breaking effort at Bletchley Park, where machines were used to help crack the Enigma cipher. Alan Turing, one of the central figures in this effort, didn't just help win the war. He helped define what a computer is. His theoretical work on computation created the blueprint for everything that followed. After the war, computers slowly escaped the military and entered universities and corporations. But they were still exotic beasts. You didn't sit down at a keyboard. You submitted stacks of punch cards. You waited hours or days for results. Programming was not interactive. It was ritualistic. Then, in the 1950s and 60s, something extraordinary happened: the transistor. Vacuum tubes were replaced by tiny solid-state devices that were faster, smaller, and vastly more reliable. This single invention changed everything. Computers began shrinking. Power consumption dropped. Failure rates plummeted. And suddenly, computers weren't just for governments. They could be built for businesses. As transistors became integrated into chips, entire circuits could be etched onto silicon. This was the birth of the integrated circuit, and later the microprocessor. Instead of a room full of hardware, you could now fit a computer onto a board. Then onto a single chip. In 1971, Intel released the 4004, the first commercially available microprocessor. It was less powerful than a modern calculator, but it carried the entire idea of a computer inside it. That's when the personal computer revolution began. In garages and basements, hobbyists started building machines that normal people could own. The Apple I, the Altair 8800, the Commodore PET, these were not sleek or user-friendly, but they were revolutionary. For the first time, computing power belonged to individuals, not institutions. The 1980s turned computers into household objects. IBM PCs standardized hardware. Microsoft provided operating systems. Apple pushed graphical interfaces. Instead of typing cryptic commands, people could click icons. Instead of programming to use a machine, you could just use it. This accessibility changed society. Businesses, schools, and families all began to rely on computers. And then came the internet. At first, it was just a way for computers to talk to each other. Scientists wanted to share data. Researchers wanted to collaborate. But once the World Wide Web arrived in the 1990s, computing exploded into something completely new. Computers were no longer isolated machines. They became portals into a shared global mind. Email replaced letters. Websites replaced encyclopedias. Search engines replaced memory. Suddenly, computing wasn't just about calculation. It was about information. As hardware continued to improve, software grew more ambitious. Operating systems became more complex. Applications became richer. Games became entire worlds. And behind the scenes, invisible systems were coordinating everything: databases, servers, protocols, networks. Then smartphones took everything that used to sit on a desk and put it in your pocket. GPS, cameras, web browsers, payment systems, social networks, all became apps. The computer vanished as a visible object and became an invisible layer over daily life. Today, we live inside computation. Algorithms decide what we see. AI systems write, draw, recommend, and predict. Data flows constantly between devices. The computer is no longer something you use. It's something you inhabit. And yet, at its core, nothing has changed. Every modern supercomputer still runs on the same fundamental idea as the Abacus. You have states. You apply rules. You get results. Whether it's beads, gears, transistors, or neural networks, computing is still about turning inputs into outputs through structured logic. The history of computing isn't just a story about machines. It's a story about humans trying to think more clearly, remember more accurately, and extend their minds beyond the limits of their skulls. Every calculator, every program, every chip is a piece of that ancient dream, to make thought tangible. And we're only getting started. Buckle up and consider leaving your mark on the biggest revolution in human history.